Have you heard the story of a thirsty crow who finds a bit of water in a container? But he can't reach it because it is at the bottom of the container. So he picks up stones lying nearby and drops them into the container to make the water come up so that he can drink it. And the water does come up. But could it have come up high enough for him to drink? What do you think? You must have learned that the Earth rotates around a tilted axis. What is an axis? Is it a stake, real or imaginary, that goes through an object? When we say the axis is tilted, what is it tilted with reference to? Have you thought about these questions? We go to school and college to learn, to gather knowledge. We are expected to learn that a solid object has its own volume and shape, while a liquid has its own volume but takes the shape of its container. Sometimes we also learn to apply the knowledge we have gathered. So in school we are expected to apply a knowledge of arithmetic to find solutions to arithmetic problems. And if we study physics, to use our knowledge of gravity and motion to calculate the path of a cannonball. But to really understand, to be really educated, we need to question what we think we know and what our textbooks tell us. And we need to be able to apply our knowledge not just to mechanical high-speed problems, but also to arrive at thoughtful, innovative solutions. Now, it's important to be able to figure out why we should believe all that we learn. Why should we believe that the Earth goes around the Sun, though our experience tells us that the Earth is stationary and that it is the Sun that moves? It is also important to learn how to learn more on our own, to inquire, to use our knowledge and understanding to create new knowledge, to innovate. In May 2014, there was a 5-day workshop at ISA, Pune, for a group of 9th grade students. It was organized jointly by ISA Pune and Think, a team devoted to inquiry-oriented and integration-oriented education. The workshop experimented with a different way of learning in the classroom, where the goals are to develop our inquiry abilities, to integrate what we otherwise learn as fragments in different subjects, and to see the connections between everything that we learn. The videos you're going to watch, available on YouTube and on DVD, are made from the recordings of the sessions from that workshop. As we have already mentioned, the videos illustrate two goals that this kind of education is committed to. One is to help school and college students develop the capacity for inquiry in all domains of academia. It seeks to develop the capacity to think like a mathematician, like an experimental scientist, like a theoretical scientist, like a historian, like a philosopher, and so on. The other goal is to bring out the interconnections and shared characteristics across what are now seen as different subjects and disciplines. This requires two kinds of integration. One is multidisciplinary integration, which brings together knowledge from many disciplines to pursue any particular question or problem. For example, to understand the human mind, we need to bring together insights from genetics, neuroscience, psychology, anthropology, philosophy, and computer science. We also need to do transdisciplinary integration. Here, we explore concepts that cut across disciplinary boundaries, such as system, structure, function, change, history, development, evolution, correlation and causation, explanation and theory, and so on. This also allows us to integrate the different modes of inquiry, or ways of finding out, that are shared across disciplines. If these videos arouse your interest and curiosity, you can find out more about this enterprise at the Think website, www.schoolofthink.com. You can also access a wide range of educational materials at that site. This work was made possible by generous funding from the Department of Science and Technology, Government of India.